All right, everybody. So right now I'm going to be doing a couple more of these example problems real quick. I'm going to start with this one. So this one right here, if I have 2.105 times 10 to the 24th number of atoms, how many moles of that? Okay, how many moles? It doesn't really matter that it's carbon, but if you want to say moles carbon, then right here we're just going to say atoms carbon. Not up there, but down here rather. Okay, so we're going from atoms to carbon to moles of carbon. And instead of writing carbon, you just write C. So I have right here 2.105 times 10 to the 24th. And again, I'm talking about atoms of atoms carbon. Okay, and I want to get over here into moles carbon. So this right here is using straight up just a one-step conversion for Avogadro's number. So I put right here atoms on the bottom, moles on top, and right now it is 6.022 times 10 to the 23rd atoms for every 1 mole. Okay, so the last thing that we need to do is a little bit of math right here. So I'm going to do it one way. I'm going to go 2.105 EE 24. So that's times 10 to the 24th divided by 6.022 EE 23. Enter, and I get 3.5 moles of carbon. Cool, cool. We did this one together in class, but here you go, I can see it. Let's go ahead and do this one right here. One thing is this is 10.4, not 10.1 if you didn't update that. So I look over here and I have 1 oxygen, so I need to get this up to 2. So let's balance this bad boy. So I have 2. Now look at my hydrogens, and I have 4. Gives me 4. Give me 2 there, and this is going to be a 1 and a 1. So balancing is super important. Next thing I have is I have this many atoms of 10, and I want to know how many grams of water. Okay, so I want to know grams of H2O. Okay, so let's go ahead and set this up. So first thing right here is this is what I'm going to start with. I have this many atoms of 10, and I want to know how many grams of H2O. Okay, well, the first thing that we know for sure is that we can go from atoms to moles. This is kind of what we've been practicing on this one right here. So I have, it also applies to molecules. So it's actually just like this. And check this out. You can actually leave out the elements right here, because if I have atoms or molecules, we're gonna say atoms. Atoms cancels out with atoms. I'm still left with 10 on the top, and 10 is fine. So now I have moles of SN, and I want to know how many moles of H2O that is. Okay. Cool. And once I have moles of water, I can get into grams of water. All right. So this one right here, I've already done moles to moles. I have SN is right here. It's actually, we're talking about this one right here. It's actually oxide, excuse me. And right here. So there is 1 of these for every 2 of these. And then this one right here is my side calculation. We've done it a bunch, but I think it's 18.015 grams for every 1 mole. Okay, cool. Now I can do this a couple different ways, but let's just do the same one as doing 3.01 E23 times 1 times 2 times 18.015 equals this, divided by 6.022 E24, and I get 1.8. So I end up with 1.8 grams of water. So in this next part, we're talking about molarity. So the first part is we're basically just getting from milliliters to liters, and this is probably the easiest. It's if you start with 350 milliliters, you just want to know how many liters it is. Doesn't matter what we're talking about, but it's a blank amount of liters. So if I start with 350 milliliters, I can put milliliters on the bottom here, liters on top, because I just want liters. Now it's HCl, but this doesn't really matter right here. So it's 1,000 milliliters for every 1 liter. And when I do the math, 350 times 1 is 350 divided by this is 350. Now, a quick way to remember this, excuse me, 0.350 is you're always just going to move the decimal 3 spots to go for milliliters. So 1, 2, 3 gives me that one. Now on this one right here, I have 2 liters, and we want to know of how many moles, blank amount of moles of HCl. All right, this one will be a little trickier. So I start here with 2 liters, and this right here I have to interpret a bit. So this part right here, 2.5 molar is equal to 2.5 moles for every 1 liter. Okay, so this 1 liter can go on the bottom, 1 liter can go on the bottom, and the 2.5 moles can go on top here. And 2 times 2.5 is equal to 5 moles. The liters cancel out. Okay. We did this one in class. One thing that's kind of a trick about this one is this one you get into moles, but you need it to be in moles per liter. You need it to get in molarity. So what you do is you just have to kind of divide by liters, leave this blank. If you want to put a 1 in here, you can put a 1 in here. That's totally fine too. Let's go ahead and do this one. When you balance this one all out, it's all equal to 1, I believe. 1 hydrogen, 1 hydrogen, Na, 1, 1. So that's kind of nice, right? So what I start here is 400 milliliters of HCl, and I want to know how many grams of NaCl. Okay, so 400 milliliters HCl. Okay, and let's see it to grams NaCl. So right here, first off, we're going to get this into liters. Okay. And I'm just going to enter this right now because it's a nice, easy one. Now, the next one is a little bit tricky. We have liters right here, and we want to get it to moles, okay? And we're going to use this part, this 8 molar, okay? So remember, 8M means 8 moles for every 1 liter. It's the concentration, okay? So if I put 1 liter on the bottom and 8 moles on top, we'll be left with moles of HCl. Now I can say moles of HCl to moles of NaCl. And right here I can say moles of NaCl going to grams of NaCl. All right, now this is a 1-to-1 relationship, and I have to do a little side hustle to get me my, this one right here. So I have to look up, it's gonna be 35.45. So it's gonna be 35.45 plus 22.99 is 58.44. That doesn't sound perfectly right. Let me see if this is correct. NA is 22.9, 35. So yeah, actually 58.44, 58.44. Now I'm just doing a little bit of calculations. 400 times 1 times 8 times 1 times 58.44 equals, and then I'm going to take that and divide it by 1,000. It's the only number on the bottom, and I get 187 grams. All right. Last one is this one right here. Very similar to this one right here. I need to balance a little bit for first. 2 NAs, so I can have 2 NAs. I have 1 CO3, 1 CLs. I need to have 2 here, and that balances right there. Perfect. And what I'm doing is I'm starting with 250 milliliters of HCl, and I want to know grams of NaCl. Okay, so 250 milliliters HCl, and give me, once again, grams of NaCl. All right, same first step right here. Okay, I'm just going from milliliters to liters. Now in this one right here, I have 2 molar, which means right here, this was 8 molar, but now I'm going to say this is 2 molar. Okay, so this turns into 2 moles for every 1 liter. That's what the 2M stands for. Now in this one right here, I'm going to have moles of HCl, and this is going to be moles of NaCl. And there's a 2 here, but there's also a 2 here. Cool, cool. And then the last step I'm going to have right here is moles of NaCl. And look at that, it's actually the exact same as this one right here. I'm just going to do a little bit of calculations. 250 times 1 times 2 times 2 times 58.44 equals divided by 1,000 and divided by 2, and I get 29.22. Holler at your boy.